In this video, you're going to create your very first asynchronous non-blocking Node.js application. And by non-blocking, I just mean that your application is going to continue to be able to do other things while it's waiting for some long-running I/O process to complete. And that's one of the things that makes Node.js so great, fast, and efficient. So in this video, we're going to explore asynchronous programming with a basic example. Then we'll take what we learn here about asynchronous programming and use it to build out our weather application. To actually get that app built, we're going to need to interact with real-time weather APIs, and that is going to require us to make asynchronous HTTP requests. All right, let's go ahead and get started with a basic example. To start, let's go ahead and close all open editors, and then down below, I'm also going to collapse that Notes app directory, and we're going to create a new folder for our new project. Right here, inside of the Node course folder, I'm going to create a new one, and I'll call this weather-app, and this is the directory we're going to end up working out of throughout the next several sections. To kick things off, we're going to create a single file inside of here, and obviously we will expand on that as we build out the application. But for the moment, a single script called app.js is going to give us all we need to explore the basics of asynchronous programming. For the moment, we don't even need to initialize npm, as in this video, we're not going to need any npm modules. Let's get started with a few well-placed console.log calls. I'm going to add one at the top of our script before all of the code we're going to write, and this will just say starting. Then we're going to add a second one after all of the code we're going to write. And console.log, this one can say something like stopping. Everything else we're going to write is going to go right in between. Now, currently, we have a completely synchronous program. In a synchronous programming model, one line runs after the next, regardless of how long each line takes to execute. Now, in this case, we have a very simple program where starting is going to run first and stopping would run after. No shock there. Now let's go ahead and actually explore how we could add a bit of asynchronous programming into this script. And to do that, we're going to use one of the most basic asynchronous functions that Node provides, and that is setTimeout. SetTimeout allows us to run some code after a specific amount of time has passed. And setTimeout is indeed a function, so let's call it as such, and it takes in two arguments, and both are required. The first is a function. So let's go ahead and for the moment, just set up an arrow function right here like this. And the second is a number. It's the number of milliseconds you want to wait before the callback gets executed. So in our case, let's go ahead and use 2000 milliseconds, which would equal to 2 seconds. So what we're really saying is, hey, here's a function. Can you run this function after 2 seconds have passed? Now let's add something inside of this function, the one we passed to setTimeout, so we can actually see that it gets called when it's supposed to. And for the moment, as you might have expected, we're just going to use console.log to print a message. Right here, 2-second timer. And by having all of these logs in place, we're going to be able to see how our program executes by running the script down below. Now, in a synchronous programming model, one thing happens after the next. So we would have the starting message print, then we would wait 2 seconds and we would see our 2-second timer message print, and finally we would see the stopping message print. With asynchronous Node.js, that is not the order we're going to get. Down below in the terminal, I'm going to use cd to change directories into the weather app. Go ahead and do the same. And once we're here, we're just going to run app.js through Node. So node space app.js. Now we'll run it a couple of times because things are going to happen pretty quick here. So I'm going to run it. And what happens? We see starting prints, then stopping prints, then the program just kind of hangs for 2 seconds, followed by the 2-second timer printing. Let's go ahead and do that one more time. Right here, you'll notice we're not getting brought back to the command prompt until those 2 seconds pass. So now our Node application does indeed take over 2 seconds to run. Then we're brought back to the command prompt where we could do something else. So that Node process is going to require just over 2 seconds. And now you'll notice the order that we're getting those messages in. We have starting printing first, which still makes a lot of sense. Then we have stopping, and finally, we have the 2-second timer printing. So in the synchronous model, we needed to wait those 2 seconds before the program would continue. In an asynchronous non-blocking model, Node can continue to do other things like run everything down below while it's waiting for those 2 seconds to pass. Now in this case, we're using something simple like set timeout to illustrate the basics of asynchronous programming, but imagine this was a database request. If we were fetching data for one user, it would be nice to be able to do other things in our program while we're waiting the couple hundred milliseconds it takes to get that information back. Otherwise, Node would be terrible at its job. Instead, with the non-blocking model, we're able to do a lot of things at the same time. I can wait for 60 database requests to come back while still issuing more. Now let's take things one step further by adding a second set timeout call into the mix and generating some strange and potentially unexpected results. Right here, I am going to add a second set timeout call, passing in the same 2 arguments. The first is our function to run after a specific amount of time has passed, and the second argument is the amount of time to wait in milliseconds. And in this case, we're going to wait 0 milliseconds, saying we want to run the function right away. Now inside of here, once again, we're just going to print a message so we can see the order in which things happen. So console.log, and I will print 0 second timer to the console. I'm going to save app.js, and down below I will use clear to clear the terminal output before rerunning the app.js script. From here, I can cycle through my previous commands to rerun the program, and let's go ahead and look at the order in which things happen. Right here, we see starting, then stopping, then 0 second timer, followed by 2 second timer. Now, I definitely expected the 2 second timer to print after 2 seconds, but why is 0 second timer coming after stopping? If I'm not waiting any time at all, it would seem that I would get this message before I would get the message down below, but clearly that's not the case. Now, to explore why, we're going to take a look at the internals of Node.js that are responsible for actually getting asynchronous programming to work. And we're going to do that in the next video with a little visualization I put together that goes over a few examples like this one, showing you exactly how they run behind the scenes. That's going to give us a better mental model for working with asynchronous programming. And then in the video after that, we'll start the process of making HTTP requests so we can fetch real-time weather data. I'm excited to talk about why things are working the way they're working in the next one, so let's go ahead and jump right in.